Now I want to consider not adding weight to the kayak. Since my kayak was only 10 feet, didn't want to add any more weight than I had to. Trolling motors varied in weight based on the amount of thrust. They usually ran from around 28-pound thrust to anywhere up to 55, 65-pound thrust. So I wanted to keep it lightweight, so the 30-pound thrust seemed to be a very common low-end trolling motor. The more thrust, the more weight you're adding, so I decided to stay with the 30-pound thrust. The battery is another huge weight consideration. Marine deep cycle batteries come in several types. The following information came from the West Marine website. There's another option, the lithium iron phosphate. It's LiFe04 is the shortened name for those batteries. They're about 6.9 pounds. Now, the phosphate battery is roughly 2 times the cost of a good lead acid battery. So you got to consider weight and cost. Now, I was lucky. I had a IRS refund, so I decided to use some of that IRS refund for the lithium iron phosphate battery. So here is my 35 amp hour lithium iron phosphate battery from Mighty Max Battery. It weighs 9.6 pounds and measures 6.9 inches wide by 6.5 inches long by 5.0 inches high. Notice how it compares to the gulp bait container. That is much smaller and lighter than any other marine battery that I've seen. The size 24 battery box was the smallest marine battery box I could locate. As you can see, the battery is much smaller than the box. It does provide room for installation of a 12-volt breaker and the necessary wiring. Lithium iron phosphate batteries need a different charger than your regular auto battery charger. This charger is from Battery Tender. It can charge either auto or lithium batteries. After I purchased it from Amazon, I also noticed it was in the Walmart automotive section. I wired 3 connection plugs to the battery. The first was to the battery charger. It had an inline fuse from the manufacturer. The second connects to the cable to the PWM controller. The third connector goes to my Lowrance fish finder. All connection lines are secured to the box with small wire ties. On the positive lead from the battery to the PWM controller connector, I installed a 12-volt breaker in the lid of the battery box. When I mount the battery in the back of the kayak, I'll put a strap that was provided with the battery case. I'll put that on for additional safety in case we happen to turn over, I wouldn't lose the battery. I added pad eyes to both sides of the battery, and that's secured with carabiner clips in the back of the kayak so that the battery box will not move or hopefully fall out. Now let's look at variable speed control for the trolling motor. To accomplish that, you'll need a PWM controller. PWM means pulse width modulation. There's a number of YouTube videos that show you how to install that on kayak. I'm not going to try to replicate that, but let me give you a couple of pieces of advice on purchasing PWM controllers. First, they're all made in China. They're very cheap parts and cheap circuit wires and connectors. You might want to look at paying a little more instead of the $15–20 range. Perhaps you'll get a little better quality. Also, you'll need to buy a PWM that's rated at 60 amps or more in order to handle the output from the battery to the trolling motor. There are two ways to install the PWM controller that I've seen on YouTube videos. This is the graphic of those two options. As you can see, we spare no expense on my channel for graphics, and this costs no expense. The top option separates the two switches from the PWM circuit board. Using a cable containing 8 stranded wires, the two switches and display can be in a smaller control box near your kayak seat, while the circuit board can be elsewhere, like in the top of the battery box. I tried this option first and it was not completely successful. The problem was the 8-conductor cable that I purchased from Lowe's. The 8-conductor wires were solid, not stranded. They were too stiff for the very fine wires of the PWM. They were more difficult to solder, and the stiff cable caused the fine wires to fail. If you choose this option, be sure your cable connector wires are fine stranded wire. Option 2 keeps the PWM circuit board, the digital display, the rocker arm forward-reverse switch, and the speed control knob together in a slightly larger project box. This is how I mounted the project box to the track of my kayak. It's 1-inch PVC, and I made this homemade track base from viewing the Kayak Hacks fishing channel on YouTube. See the episode entitled Option 1, How to Make a PVC Gearhead Track Adapter for Kayak Fishing. Run that in the track, pull up on it, turn until it tightens. Come on, tighten. There, tightens. Now, this is a 1-inch PVC 35-degree angle, and this is 1-inch PVC, but if you notice, I used my grinder to grind off the end of it so that it would fit in this 1.25 inch cap piece. So I haven't glued any of it because it fits tightly enough. Now this is a 1-inch cap that I drilled a hole in. Hold on a second, let me get. I drilled a hole in, put the head on the inside of the project box and screwed it down, and then I took a little screw and screwed it from this side so that it would not turn. Now this fits on, and you can turn it to any angle, and you can even take it off when you're getting in and out of the kayak so you don't hit it as you're moving in. So that's how I did the mounting for the project box. Here's the larger project box, and as you can see, the PWM just barely fits in there. I was able to mount the digital readout in the box, not in the lid part, but right in the base part. And here's the on-off switch, and you got a dual on-off switch. This one for the speed, that's off. You also have down here the forward and reverse. So you gotta have, for it to work, you gotta have the forward and the rheostat controller there on. Now I don't have it hooked up in the battery right at the moment, or the LED would display. I used some gland nuts that I had from a previous project, mounted them in there. I could have used terminal connectors onto the PWM board, but that would have pushed the whole project up another quarter-inch or more, and I didn't want to do that, so that I would have enough room up here for these components. So I just left bare wire and screwed down the terminals. The cables run here, and they come out here. One goes to the battery and one goes to the trolling motor. Now let me show you. If you notice, the metal prong is black on this one and red on this one. So this is the coming from the battery, so it's got a red prong that goes into the red female port. So that's how I tell which one goes to the battery and which one goes to the trolling motor. Now on the trolling motor, you can see that I connected these connectors using quick connect connectors, clamp-on connectors. Now I ordered these quick connectors off Amazon, and let me show you that packaging. Now this is the packaging. They come one per package. I don't remember how many I ordered, 3 or 4. And what you do is you cut them in half like this. Now if you notice, that's some pretty thick wire, strand wire on there, and I guess it says number 8 on here, so I don't know if that's, I don't know what gauge it is, but it's definitely a battery terminal gauge. This is one I had, and it's a much smaller gauge wire. I didn't want to use that on the battery or motor. I did use one of these on to go from the battery to my Lowrance fish finder. So use the smaller gauge on your smaller 12-volt devices and the bigger gauge on your motor and battery. Whenever you put a motor of any kind on a boat, including kayak, you're going to have to register it with your state. That's the way it is here in Florida, and it would probably be very similar in most of the rest of the states. This is the completed Railblaza style trolling motor mount project. It met my initial 4 project goals, and it appears to be sturdy and functional. Hopefully I'll get to take it out for a test drive soon. Hope you enjoyed this video. Thanks for watching. Hit the subscribe button, and may God bless.